Hello, welcome back to our CCNA series. So this will be Cisco Certified Network Associate 2025. This is our day 6 already. And we're going to do today, we're going to fill in some of the gaps on our lectures because I think we jump in right away on routing and switching, and we skip the cabling types. So this one, it's still very important topic, though this one will fall under in the like the physical layer of the OSI. So I feel like it's better to start with the switching and routing, since that that is like uh, usually caught the attention of my students. So I'd like to start with the configuration, but we have to go back with the cabling types because this is still very important. Instead of us just plugging in whatever cabling that works, so we need to know the differences between the two. So I'd like to start with uh, the fiber. So forget about the single and multi-mode for now. When we hear fiber, I think this is very common. Like there's usually like an advertisement with the ISP that okay, we do have a high-speed connection. I'd like you to offer a very high-speed connection with our fiber link, but you're going to see it's going to be like 100 Mbps plan. So I still remember like the time we're in fiber is not very common, and it usually used to advertise to the clients that this is a really high speed connection and really fast compared to the traditional. So I'd like to debunk that part because on if you're going to see it on a network level, like let's say you have a fiber connection but your plan would only be 10 Mbps. So no matter what kind of link you'll be using, you're still going to be capped on that certain speed. Let's say 10 Mbps. Let's say you have a plan of 2 Mbps and it's fiber. So what's the difference between that over the traditional? Because um, what we know, or like what we know so far, probably, or the most common probably would be the copper. That's like the Ethernet cabling, like usually color in yellow in color, the one you always see on the back of your computer and connected to your router. So this is the common one. And the funny thing is, if you're going to have a Ethernet cabling over a fiber, if your speed would be just around 2 Mbps, I don't think it will ever really go up than that, regardless of what cables that you are using, because cabling in cable type is just like a mere way to communicate one device to another. The configuration, it will still be based on whatever the configuration of that network devices. Let's say there will be like fewer latency on fiber, like there could be like a fewer latency drop, but I don't think that's something that will make a huge difference over the speed that will be configured on your connection. So I'd like to start with this one, the Ethernet fiber. If you're going to look at that connection, so we have like it should be 100 meters, lower bandwidth, because for bandwidth, usually when we have like a copper cabling, like the common one would be the Cat 5, it can only handle like 100 Mbps. So aside from uh, it's only good for 100 meters, because what will happen is that if you have two computers and then you connect it with a copper cable and it's already more than 100 meters, like it's already more than or like more than 100 meters, what will happen, you're going to start receiving packet drops on your links on your connection. So though it's still going to work, but you're going to see a lot of drops when that happens. So you also need to check the distance between one computer to another. And aside from that, it says here there's lower bandwidth, but the bandwidth that we say lower, like for example, the Cat 5, 100 Mbps. So if you're going to have a plan more than 100 ps, the only time that copper and fiber will matter is that if you're going to use a Cat 5 cabling, and then you have internet speed of 200 Mbps. So no matter how fast your internet speed is, you're always going to be capped on the 100 Mbps. So you either choose higher level for this one, like we have a Cat 5e, which I think can handle like 1 Gbps, or a Cat 6 that can handle like 10 Gbps. Because if you're going to these are merely like the model of the copper, because we have the Cat 3, Cat 4. You can search that through the net. What's the speed? I think there are copper cabling that can only handle like 10 Mbps or 1 Mbps depending on the cable type. So that's the only time that this will matter. And usually, if you're just like inside the building, you can use the copper cabling, because 100 meters, that's enough for us to connect devices on the production, or let's say where those computers are connected, and then going to the server room. Now, if your cabling or if your connection would go up with mm, like more than 100 meters, that's the time that you need to choose between uh, or that's the time that you'll choose a fiber cabling, and either choose and check what's the difference between single mode and the multi mode cabling. Usually for this one, it's really more on the ISP level, because if you're going to aside from they are more expensive compared to the Ethernet cabling, it's not just worth it to use fiber links uh, on like on the office setup. So like what I mentioned, aside from the cabling is much more expensive, it doesn't really make sense to use a very high speed connection if the limit or the maximum speed that you can only handle would be like 10 Mbps or 100 Mbps. Because aside from cabling links, if you've heard, there's also like a transceiver that will cost additional when you choose between these cable types. That's where you need to connect those fiber links in order for you to connect it to a certain port. Now, let's choose the difference between the single mode. If you're going to see, it's a smaller core, up to 200 kilometers. While the multi-mode, it's a larger core, but the distance, though it's way better in terms of the distance it can handle, 2 kilometers, over 100 meters. The single core would look at that, 125 miles, 200 kilometers. It's also the difference between the distance is huge, really huge. But if you're going to see why is that, there's a core size here, and if you're going to see fiber cabling, the core size is like the hole in the middle. So this is like a multi-mode. If we're going to provide illustration on that definition, let's say this one is 9 micrometer. So the symbol for this one, that means micro. So this is like a micrometer. That's why if you're going to see like configuration on Cisco devices like this one, this is like a microseconds. So that's how you read that. And what's that for? It's just like the hole we're in that uh, fiber, like the light from the fiber. Like if you're going to see if you've seen a fiber cabling, when you plug in into one device and it's already up, you can use it as a laser. So that's where that core is. So if you're going to compare the multi-mode, it's way bigger compared to the single mode, and that's also the reason why it can travel uh, way far compared to the multi mode because it's much more concentrated because that's where we transfer data that the light uses by those fiber links. So of course, if it's much more concentrated, even not in network level, if you're going, even in your using a hose and a water, if you try to control the flow of the water, like put your fingers on it, it will be much more slim compared to the regular hose, but it can reach far. So it's the same logic with the fiber links. So that's the main difference between the two. And like what I told you, so it's also consideration. The only time that this will matter would be to choose between um, the distance. Like if you're going to have a higher or longer distance to connect devices, of course you have to choose the single mode. Though this one will be much more expensive, uh, it will be appropriate to use this kind of type if it'll take like more than 100 kilometers. Because for multi-mode, that will only like around 2 kilometers maximum before it started losing the it started losing the light from one device to another. Okay. So I think that's it. It is really easy. Like if you're going to identify these three. So these are the topics from Cisco. I just get this. You can go to the Cisco website, Cisco, and then list the topics that you have. So this is something that we've skipped, and we jump over to the network and switching. So yep, just check it out. And the last part would be the Ethernet shared and also point to point. Um, Point to point, by the definition, I'd like to start with the point to point. So by the definition itself, uh, you'll understand what that means. It's just basically saying that the connection type would be used by one network to another straight. So one best example for this one would be the lease line. So if you've heard the lease line, it's just another service by the ISP. Like if you're an enterprise company, you have the chan or you have the option to choose with different setups. So if you've heard the lease line, that's the most expensive, uh, usually the most expensive service from ISP because what it does, let's say you have office, what happened? Okay, let's say you have office here, and what happened to my? Okay, so let's say you have office here. Let's say this is in the US, and um, like let's say Mexico City, and you have a specific data center to connect. So you have the option to choose the public that they were going to provide you a public IP, and then you connect it over the internet, and you can just set up VPN from your office to going to your data center, or you can use a lease line, which is like a dedicated line. So they will plan the cabling from your office going to this specific data center, and the farther the distance is, the more expensive this one is because you're not sharing that network devices to anyone. Because for public or for though the public IP itself, like the enterprise setup, it's already expensive compared to the one that we know on the home setup. You're still going to share with the uh, like the share a connection with the uh, clients within that area, because at the end in the end you're going to plug in on a specific core devices of that ISP to connect to the whole network itself. So that's why direct dedicated communication, no collision. So when we say no collision, that's because when we say when we discuss the internet shared media, that's where we uses the unswitched Ethernet hubs, And basically, what does that do is that if your computer A here and computer B, and you have computer C here, the collision domain is that if you're going to send one data from A to B uh, in setup or in shared collision domain, it will also possibly received by C. And if you have like computer D here, even though the packet it's only designated to B, it will just throw that packets to whatever uh, devices or networks connected to that devices. So those are the main difference between Ethernet, shared media, and also point-to-point connection. So I think that's all for our topic today. So it's overview. It's just for us to identify what are the different connections that we can use, and usually the setup that we have, and also what are these cabling types. So again, more cabling types is a matter of choosing between what will work for you in terms of the distance and also in terms of the speed. And I hope you guys learn something from this lecture. And if you have questions, you feel free to add a comment on our comment section. That's it for today. Thank you so much, and see you again next week.